Good day students, I'm Daniel Barnard. I am the Fluid Lab Technician, and this video will go through the pump characteristic curves lab that you need to do. In this video we'll go through your lab guide. I'm going to show you the equipment we're going to use and the procedure how the data is captured. The raw data will be provided to you and able to do this online lab. Next section, let's quickly go through your lab guide. Here's the lab guide, just at the front page. Then we have the index. First page, point number 1, the aim of the experiment, and it's to determine the head versus flow, power versus flow, and efficiency versus flow curves for the centrifugal pumps, and then compare it with the published pump curves. Section 2, there's what you need to do and what you need. Please have a read through that. Then we have some theoretical background explaining pump heads and efficiency and all those things. That's still part of theoretical. Next section is the experimental apparatus we're going to use. There's a picture of the pump station and with descriptions of what's what. We will also go through the equipment in the next video section. That's the control panel for the pump station. Next point is the experimental procedure, which we'll also cover in the videos. Then the results. What we want to be, for results of this lab, we obviously need to plot some graphs there. And there in bold, please note that the theoretical pump curves and the experimental pump curves will be at different speeds. So it's very important to use the affinity laws to be able to compare results. Then Appendix A is the pump curves. This is the theoretical pump curves for the pump we're going to use. And over there you can see that the RPM for this pump curves is 2,900. And we will do the lab at 2,500. So you need to use the affinity laws to be able to compare the two. Then Appendix B, this is what the data table will look like, which you will receive. There you have the inlet pressure, outlet pressure, motor speed, torque, and the volume flow rate. And then some of the values need to be calculated. Down here, there's an explanation of the data and what you will receive and what the student must calculate. Next video, let's have a look at the equipment. The pump station we'll be using. So we have two pumps on the left and then the control panel for the two pumps. Let's start on this side. We have two pumps, pump number 1, pump number 2. Here at the back we have sensors. This is torque sensors. Then obviously the electrical motors that drives the pump. We're going to measure the electrical inlet power. And then over here on the shafts, the speed, the RPM of the shaft is measured. And again, pump 1, pump 2. And these big lines, this is the suction lines, the inlet lines. And then these over here is delivery lines. This little red sensor is pressure transducers. Here's the inlet pressure for pump number 2, there's the inlet pressure for pump number 1, and this is the outlet pressure for pump number 2, outlet pressure for pump number 1. And then if we follow these lines, they join into one, they come down all around through here. This is a control valve, so I can control the flow of the pumps, and this is a electromagnetic flow meter, and then the water is delivered back into the reservoir. These blue valves over here, we're going to make use of them to connect the pumps in series and parallel. If we want only one pump to run, we make sure we isolate pump number 2 and also the interconnecting line, and then we have to make sure that pump number 1 is open. Then when I switch pump 1 on, the water will be sucked through pump 1 and delivered, and it can't interfere or go into pump number 2. If we want to connect it in series, which means pump number 1 needs to deliver water to pump number 2, we open the interconnecting line so it will deliver water to pump number 2, and then we also have to make sure pump number 2 is open, and close the delivery line for pump number 1. Now the water will be pumped from pump number 1 to pump number 2 and back to the reservoir. If we want to make a parallel connection, we want to close the interconnecting line and make sure pump number 1 is open and pump number 2 is open. In this case, both pumps will suck water from the reservoir and both will deliver into the same delivery line. So that's in parallel connection, and the previous one series. Then the control panel. The top numbers is for pump number 1, and the bottom numbers is for pump number 2, and this one sitting here by its own is the flow meter, because we only have one. Then this is the inlet pressure, that's the outlet pressure, that's the pump speed, this is the torque, and this one is the electrical power in. Also we'll have here is the on-off buttons for pump number 1 and pump number 2, and this is a variable speed drive, so we can adjust the pump speed for both pumps. For pump characteristic curves lab, we're going to make use of pump number 2. So we make sure that the outlet valve for pump number 2 is open, and we're going to close pump 1, and we're also going to close the interconnection line. Then we're going to make sure that the control valve is fully open, and once it's fully open, we can start pump number 2. There you can see it's having outlet pressure, and then we just need to adjust the speed with the speed drive, so that's at 2500. There we go, and then we can see the maximum flow through pump number 2 with the control valve fully open. So that will be our first data point, and we capture the inlet pressure, the outlet pressure, the RPMs, the torque, and the electrical power in. Then for our next data point, all we need to do is we're going to close this control valve slightly, so that our flow value drops about 2 to 3 cubes per meter per hour. Alright, so we close it a bit. We're just waiting for the flow value to settle. It looks quite stable, so that will be our next data point. And then we continue doing this incrementally. We close it slightly. We wait for the flow to settle. And that looks quite stable, and that will be our third data point. So we continue doing this incrementally until the flow value, the last flow value, is between 0 and 1. The raw data for the pump characteristic curve lab will be provided to the student, and the student also needs to make some calculations for the rest of the values. Please take note of the constants in your lab guide that's needed to do the calculations, and also remember that the theoretical pump curves is at an RPM at 2900, and the experimental data is at an RPM of 2500. So the affinity laws needs to be applied to be able to compare the theoretical with the experimental values.